that we all have the same thing in our graphic or in our flip book. So yesterday in the first circle, we have a central angle there. And we said for a central angle on that first one, the measure of the angle equals the measure of the arc. So the measure of angle AVC equals the measure of arc AC. The measure of arc AC equals the measure of angle AVC. So for central angle, the angle and the arc are the same. Well, for today, we're going to talk about inscribed angles. So we're in section 12.3. And I'm going to write down what we just said just to emphasize it. So I'm just redrawing the picture that's in your flip book. This is V, A, and C. This is a central angle. The vertex is at the center. And for a central angle, the way I think of it is the angle equals the arc. So the measure of angle AVC equals the measure of arc AC for central angle. Well, what we're going to talk about today are inscribed angles. So the first thing we need to know is what an inscribed angle is. Well, inscribed means literally written inside. Scribe means write, in means in. So an inscribed angle is written inside the circle. So what we're saying here, draw a picture. For an inscribed angle, the vertex is on the circle. And the picture that's in your flip book is not the second one, but the third one. And I'm going to label this like your flip book. So this is an inscribed angle. Angle AVC is an inscribed angle. The vertex is on the circle. And our theorem for inscribed angles, I'm not going to write inscribed angle theorem, our book calls it the inscribed angle theorem, but that's fine. I'm just going to talk about how the angle and the arc are related. We call this the intercepted arc. So we have an inscribed angle and we have an intercepted arc. I'm going to highlight, there's my arc AC. The way those two are related is, and this is what you're going to want to put in your flip book, the measure of angle AVC is equal to half the measure of the arc. Or, the other way you can think about that is the measure of arc AC is 2 times the measure of angle AVC. And the way I think about this is to go from the angle to the arc, multiply by 2, and to go from the arc to the angle, divide by 2. So that's our key idea of today. When our vertex is on the circle, the measure of the arc is twice the measure of the angle, or the measure of the angle is half the measure of the arc. So this is going to be the information that you put in your flip book for the inscribed angle. And that's the third one. And you might want to write inscribed angle or vertex is on the circle, something like that. For the first one, you might want to write central angle, vertex is at the center, just to as a reminder. All right, so questions about inscribed angles. So everything that we talked about today is going to have to do with an angle whose vertex is on the circle. And we will have something in a little bit to add to the fourth circle in our flip book. We will wait for the second one till block day. All right, so let's look at an example. Very typical example from chapter 12. This is the kind of thing that you see. We'll see these kinds of pictures a lot in chapter 12. So there's that. Oh, that's not where I want that. Sorry. There we go. Okay. And I'm going to say this angle is B degrees. This angle is 52 degrees. We'll call this B, C, A. This arc is 56 degrees. And this arc is A degrees. And we want to find A and B. Well, let me highlight this arc that is marked here. Is that arc, that 56-degree arc, is it intercepted by any angle there? Isn't it intercepted by that inscribed angle? So we know that the angle is how much of the arc? What did we just say? Half. To go from the arc to the angle, divide by 2. So B is 56 divided by 2, which is 28 degrees. Let me change my highlighter. Here's a 52-degree angle, and here's the arc that it intercepts. So we know to go from the angle to the arc, we multiply by 2. So the measure of the whole arc, AC, this whole green arc that I marked there, is 2 times 52, which is 104. Well, this part's 56, so we can figure out A, right? A is going to be 104 minus 56, which is 48 degrees. So A would be a 48-degree arc. All right, questions? So on your circle puzzle angle partner quiz, your circle puzzle partner quiz, these are the kinds of problems that you're going to solve, going from the angle to the arc, going from the arc to the angle, figuring out those missing pieces, just like we did with triangles, where we figured out the missing angles in our triangles. Here we're finding out missing arcs and angles in circles. All right, some corollaries of our theorem. And remember, corollaries are just other theorems that we can figure out easily once we know our main theorem. The first one is two inscribed angles that intercept the same arc are congruent. So our picture here, we have two inscribed angles. There's one, and there's two. And I'm going to say that's A and that's B. Because these two angles intercept the same arc, this arc here, we would say that angle A is congruent to angle B. They intercept the same arc, so they have to be congruent. So that's our first corollary. Second one, an angle inscribed in a semicircle is, and I'm going to draw the picture here, I think we can figure this one out. So a semicircle means how much of the circle? Half. A semicircle is half a circle. So we're going to inscribe an angle in a semicircle, like so. Well, let's think about the rules that we just talked about. Half a circle is how many degrees? Well, how many degrees in an entire circle? 360, so half of it is 180. Well, if this arc is 180, to go from the arc to the angle, what do I do? Divide by 2. Half of 180 is 90. An angle inscribed in a semicircle is a right angle. So the measure of angle C is 90 degrees. So if we inscribe an angle in a semicircle, it has to be a right angle. And the third one, the opposite angles of any quadrilateral remember, quadrilateral, four-sided shape, inscribed in a circle, are supplementary. So our picture for this looks like so. Any quadrilateral that we inscribe, any four-sided shape, doesn't have to be anything special. I'm going to call this A, B, C, D, and that's a big point there where they intersect. Measure of angle A plus the measure of angle C is 180, and the measure of angle D plus the measure of angle B equals 180. And this makes sense because if I look at this arc for intercepted by angle A and this arc intercepted by angle C, together they make up the whole circle, 360 degrees. So together the arcs make up 360 degrees. To go from the arcs to the angles, we divide by 2. So together the angles have to be 180 degrees. So that's with corollaries. We could say we could figure them out easily from our original theorem. All right, questions there? Okay, let's look at a couple of examples where we apply some of these corollaries. This first one, I hope, is really easy. That's the center of the circle, and I'm going to call that 1, and we want to find the measure of angle 1. Do we have to do any computations here? What part of the circle is this? Half, because this is a diameter. This is an angle inscribed in a semicircle. So what is that angle? Measure of angle 1 is 90 degrees. It's inscribed in the semicircle. That's all we have to do. It's inscribed in the semicircle. We know it's 90 degrees. Let's look at this one. You'll see lots of pictures like this in this chapter. So I want to undo that. That one doesn't go through the center. There we go. That doesn't go through the center either. There we go. Call that 2. 43 degrees. That arc is 128 degrees. And I'll call this C, B, A, and D. And we want to find measure of angle 2. Couple of different ways that we could do this one. Well, here's angle 2. And here's the arc that it intercepts. Is there another angle there that intercepts the same arc? Hmm? 43. So, is there another angle that intercepts that arc? The arc AB? Angle D intercepts arc AB. So angle C and angle D intercept the same arc. So what does that tell us? They're congruent. Angle D is congruent to angle C. So the measure of angle 2 is 43 degrees. If we didn't remember that, well, we could say, oh, to get from the angle to the arc, we multiply by 2. So measure of arc AB, so this is the first method. The second method, we could say the measure of arc AB is 2 times 48. Sorry, 2 times 43, which is 86. And then to go from the arc to this angle, we divide by 2. So the measure of angle 2 is 86 divided by 2, which is 43. So we can do it either way. Either way works fine. Questions? All right. Another theorem. This one doesn't have a special name. I'm going to start by drawing a picture. This time we have a chord and a tangent. So we have a situation like this. There's a chord, and I'm going to draw a tangent line. All right, so here we have a tangent and a chord. The vertex is on the circle. The angle is half the intercepted arc. So it's the same rule. To go from the arc to the angle, you divide by 2. To go from the angle to the arc, you multiply by 2. And in your flip book, the fourth picture, it says that line VC is tangent to the circle. So why don't I change my letters here to match what's in the flip book. A, that's C, this is V. It says VC is tangent to the circle. So in your flip book, the measure of angle AVC is 2 times the measure, is the measure of arc AC divided by 2. And the measure of arc AC is 2 times the measure of angle AVC. So this is what you're going to want to write in your flip book. And you might want to draw the little diagram. The vertex is on the circle. Our rules for angles with the vertex on the circle are the same. The vertex is on the circle. The angle is half the arc. The arc is twice the angle. All right, questions there? Okay, let's look at an example using this idea. So here's our setup. All right, I'm going to say that line AC is tangent to the circle. At B. The measure of angle or arc BED is 214 degrees. Find the measure of angle DBC. All right, so the problem tells us that the measure of arc BED, this whole thing around here, is 214 degrees. So there are a couple of different ways that we can go about doing this. The first way I thought of was, well, how far is it around the entire circle? 360. So can't we find this arc? If the whole circle is 360 degrees, how would we find the measure of arc DB? Well, 360 degrees around the circle. We know 214 of it. How do we figure out the rest? We subtract. So the measure of arc DB is 360 minus 214, which is 146. So this is 146 degrees. And now to go from the arc to the angle, what do? Since the vertex is on the circle, divide by 2. So the measure of angle DBC is 146 divided by 2, which is 73. So that's the first method that I thought of. The second method. Well, can't we figure out what that angle is from this arc? This vertex is on the circle. Don't we divide by 2 to get that arc? Or sorry, that angle? So our second method, we could say the measure of angle DBA is 214 divided by 2. Well, 214 divided by 2 is 107. So this angle is 107 degrees. And what do we know about these two angles? What is this? It's a line. So what do those two angles have to add up to? 180. They're a linear pair. So the measure of angle DBC has to be 180 minus 107, which is 73 degrees. So that'd be the second method you could use. All right, questions? Okay, that's all for today. Oops, cancel homework. It's 784. 6 or 24 even, 28, and 32.